Now, in this lecture, we'll find out the area of the green shape using two different methods. In the drawing, we have a circle. Inside this circle, we have triangle ABC. We know that side AB of this triangle ABC equals to 13 units in its length, side BC equals to 14 units in its length, and side AC equals to 15 units in its length. Our mission is to find out the area of this green shape. So first of all, I will present to you rule number 4, and we will implement rule number 4 in our drawing. According to rule number 4, we have here triangle ABC. You know that side AB of this triangle ABC equals to A units in its length, side BC equals to B units in its length, and side AC of this triangle ABC equals to C units in its length. So according to rule, and the semi-perimeter of this triangle ABC equals to the perimeter that is A plus B plus C, that is the sum of its side lengths over 2. Again, the semi-perimeter S equals to the perimeter that is A plus B plus C over 2. And according to this rule number 4, the area of triangle ABC equals to, here the square bracket is the sign for the area, so the area of this triangle ABC, that could be any triangle, equals to the square root of S. S is the semi-perimeter, that is equals to A plus B plus C over 2. So it is the square root of S times S minus A times S minus B times S minus C. So actually we can implement the new rule number 4 in our drawing. So first of all, we define side AB of this triangle ABC as A, and you know that AB equals to 13. We define side BC of this triangle ABC as B, and we know that B equals to 14 units in its length. And finally, we define side AC of this triangle ABC as C, and you know that AC equals to C, and C equals to 15 units in its length. So I write it down here. According to our definition, A equals to 13, B equals to 14, and finally C equals to 15. In the next step, we will find out the semi-perimeter of this triangle ABC. According to the new rule number 4, the semi-perimeter of any triangle equals to A plus B plus C, that is the perimeter, over 2. So S equals to A, that is 13, plus B, that is 14, plus C, that is 15, over 2. 13 plus 14 is 27, plus 15 over 2. 27 plus 15 is 42, and 42 over 2 is 21. So finally we found out that the semi-perimeter of this triangle ABC equals to 21 units. And according to the new rule number 4, the area of our triangle ABC will be equal to the square root of S times S minus A times S minus B times S minus C. So it is equals to the square root of S. S is 21. S minus A is 21 minus 13 times S minus B. S minus B is 21 minus 14 times S minus C. S minus C is 21 minus 15. So the area of our triangle ABC, according to the new rule number 4, is equals to the square root of 21 times 21 minus 13 is 8, times 21 minus 14 is 7, times 21 minus 15 is 6. So the area equals to the square root of 21. We can substitute 21 by 3 times 7 times 8. 8 is 2 times 2 times 2. So we substitute 8 by 2 times 2 times 2 times 7 times 6. We will substitute 6 by 3 times 2. Now we will rearrange the numbers here, and we get that the area of our triangle ABC according to the new rule number 4, it is equals to the square root of 3 times 3 times the square root of 7 times 7 times the square root of 2 times 2 times the square root of 2 times 2 again. So we actually found out that the area of triangle ABC equals to the square root of 3 times 3 is 3 times the square root of 7 times 7 is 7 times the square root of 2 times 2 is 2, and we have again times the square root of 2 times 2, that is 2. So the area of triangle ABC in total equals to 3 times 7, that is 21, times 2 times 2. 21 times 2 is 42, and 42 times 2 is 84. So we actually found out that the area of triangle ABC in total, the area of our triangle ABC equals to 84 square units. Repeat again, the area of this triangle ABC according to the new rule number 4 equals to 84 square units. In the next step, I will present to you a new rule, and we will implement the new rule in our drawing. This is rule number 6. So in the drawing we have triangle ABC. The length of side AB of this triangle ABC equals to A units, side BC equals to B units in its length, and side AC equals to C units in its length. According to our definition, the radius of this circle is R. This circle blocks triangle ABC. According to rule number 6, the radius of this circle that blocks triangle ABC, again, the radius of a circle that blocks triangle ABC is equals to R equals to A times B times C, that is the multiplication of the side lengths of the triangle ABC that is blocked by this circle over 4 times the area of this triangle ABC that is blocked by this circle. Again, the radius of the circle that blocks triangle ABC equals to A times B times C over 4 times the area of triangle ABC that is blocked by the circle. So we can actually implement rule number 6 in our drawing, because in our drawing we have a circle that blocks triangle ABC. According to the new rule number 6, the radius of the circle that blocks triangle ABC must be equal to A times B times C over 4 times the area of triangle ABC that is blocked by the circle. But we have already found out that the area of triangle ABC that is blocked by the circle is equal to 84 square units. So the radius of the circle that blocks triangle ABC equals to A, that is 13, times B, that is 14, times C, that is 15, over 4 times the area of triangle ABC. The area of triangle ABC equals to 84 square units. Here we divide both the numerator and the denominator of this expression by 14. In the numerator we have 14, so 14 over 14 is 1. So after we divide the numerator by 14, we left only with 13 times 15. We divide the denominator of this expression by 14 also. So in the denominator we have 4 times 84 over 14 is 6. So in total, after we divide the denominator by 14, we left only 4 times 6. Here we will divide this expression, both the numerator and the denominator of this expression, by 3. So in the numerator we have 14 times 15. In the numerator we have 13 times 15. So it is 13 times 15 over 3 is 5. So in total, after we divide the numerator by 3, we left only with 13 times 5 over, we divide the denominator also by 3. So the denominator we have 4 times 6. So it is 4 times 6 over 3 is 2. So after we divide the denominator by 3, we left only with 4 times 2, that is 8. And 13 times 5 is 65. So in conclusion, we found out that the radius of this circle that blocks triangle ABC equals to 65 over 8 units. Write it down. The radius R of this circle that blocks triangle ABC is equals to 65 over 8 units. Our mission is to find out the area of the green shape. From the drawing, it is very easy to see that the area of this green shape is equals to the area of the circle minus the area of triangle ABC. So I write it down. The area of the green shape, in total, it is equals to the area of the circle minus the area of triangle ABC. The area of the circle is equals to pi r squared minus the area of triangle ABC. Repeat again that we already found out that the area of triangle ABC equals to 84 square units. The area of the circle is equal to pi r squared, but r equals to, so it is pi times r is 65 over 8. So if r is 65 over 8, it means that r squared is 65 over 8 squared. So in total, the area of the circle equals to pi times 65 square over 8. Pi times 65 over 8 square minus the area of triangle ABC, that is 84 square units. This expression in total, it is equals to 207.394 square units minus the area of triangle ABC, that is 84 square units. So 207.394 minus 84, it is equals to 123.394 square units. So we actually found out that the area of the green shape, according to the first method, is equals to 123.394 square units. Repeat again. The area of this green shape, according to the first method, it is equals to 123.394 square units. So we finished with the first method. In the next step, I present to you how to find out the area of this green shape according to the second method. In the second method, we'll do a construction, that is to say from point A, we'll draw a perpendicular on BC. So actually, this angle equals to 90 degrees, and this angle also equals to 90 degrees according to our construction. We'll define the touching point of the perpendicular from point A and BC as M. We'll define the length of side AM as H. And we'll define the length of side BM as X. It is given us the question that side BC equals to 14 units. According to our definition, side BM equals to X, therefore CM must be equal to CB minus MB. So CM equals to CB, that is 14, minus MB, that is X. So in total, CM equals to 14 minus X. CM equals to 14 minus X in its length. So in the next step, I'll copy the right triangle A and B in a new page, and we will implement on this right triangle A and B the Pythagoras theorem. Okay? So actually, this is the right triangle A and B that they copied from the original drawing. Side AB equals to 13 units according to what is given as the equation. AM equals to H and BM equals to X according to our definition. Here by PT is a abbreviation for Pythagoras theorem. So according to the Pythagoras theorem, in this right triangle A and B, we'll get that the square of the hypotenuse equals to the sum of the squares of the perpendiculars. That is to say, AB squared equals to AM squared plus BM squared. AB is 13, therefore AB squared is 13 squared, that is 169, and it is equal to AM squared. AM is H, therefore AM squared is H squared plus BM squared. BM is X, therefore BM squared is X squared. So actually find out that according to equation number 1, 169 equals to H squared plus X squared. Here we'll subtract X squared from this equation, equation number 1, and finally we'll get that according to equation number 1, H squared equals to 169 minus X squared. In the next step, I'll copy the right triangle AMC in the new page, and we will implement the Pythagoras theorem in this right triangle AMC. So actually, this is the right triangle AMC that decouples from the original domain. AC equals to 15 units according to what is given as the equation. AM equals to H according to our definition. And we have already found out that MC equals to 14 minus X. So in the right triangle AMC by PT is the operation for Pythagoras theorem. We get that AC squared equals to AM squared plus MC squared. Repeat again, in the right triangle AMC, according to the Pythagoras theorem, we get that AC squared equals to AM squared plus MC squared. AC is 15, therefore AC squared is 15 squared, that is 225. And it is equal to AM squared. AM is 8, therefore AM squared is 8 squared, plus MC squared. MC is 14 minus X, therefore MC squared is 14 minus X squared. In conclusion, we found out that according to equation number 2, 225 equals to X squared plus 14 minus X squared. Here we subtract 14 minus X squared from this equation number 2, and finally we get that according to equation number 2, X squared equals to 225 minus 14 minus X squared. This is according to equation number 2, while according to equation number 1, we have already found out that X squared equals to 169 minus X squared. So actually we have here two different expressions for X squared. Therefore, we'll create equation number 3 that states that X squared according to equation number 1 must be equal to H squared according to equation number 2. So H squared according to equation number 1 is equals to 169 minus X squared. And it must be equal to H squared according to equation number 2. H squared according to equation number 2 equals to 225 minus 14 minus X squared. Okay. So according to equation number 3, we found out actually that 169 minus X squared equals to 225 minus 14 minus X squared equals to 14 squared, that is 196, plus X squared minus 2 times 14x, that is minus 28x. So actually found out that according to equation number 3, 169 minus X squared equals to 225. Here we'll open the brackets, and we'll get, after we open the brackets, we'll have here minus 196 minus X squared, minus and minus is plus, so it is plus 28x. So in this equation number 3, we have minus X squared on both sides of the equation, so minus X squared will get cancelled. After we cancelled minus X squared, in this side of the equation we left only with 169. That is equals to, on the other side of the equation we have 225 minus 196 is 29 plus 28x. So here we'll subtract 29 from this equation number 3, and we get that according to this equation number 3, 169 minus 29 is 140. That is equals to 28x. So here we'll divide this equation number 3 by 28, And we get that according to this equation number 3, x equals to 140 over 28, that is 5. So actually found out that x equals to 5 units. Here, nice segment BM that is x is equals to 5 units. But according to equation number 1, x squared equals to 169 minus x squared. So h squared equals to 169 minus x squared. But we just right now found out that x equals to 5. If x equals to 5, it means that x squared equals to 5 squared, that is 25. So actually found out that h squared equals to 169 minus 25, that is 144. So according to equation number 1, we actually found out that h squared equals to 144. Here we take a root out of this equation and finally we get that h equals to the square root of 144. The square root of 144 is 12. So we found out that h equals to 12 and x equals to 5. So in the next step, we'll define the center of this circle as O, and we'll join points A and O together by straight line. Point O is the center of the circle, point A is the point of the circle itself, therefore OA is the radius of this circle. We define the radius of this circle as R, so OA equals to R. In the next step we will extend the radius AO by a straight line until it touches the circle. And we define the touching point of the extended radius AO in this circle as P. When you extend a straight line by straight line, the result is a straight line, therefore AP is a straight line. AP is a straight line that touches the circle at points A and P, therefore AP is a chord that passes through point O, that is the center of the circle, and we know that any chord that passes through the center of the circle must be the diameter of the circle. Therefore AP is the diameter of the circle. I write it down here that AP is the diameter of the circle because it passes through the center of the circle, that is to say from point O. And we know also that the diameter of any circle is twice as long as the radius. The radius is R, therefore the diameter AP must be equal to 2R. Here point O is the center of the circle, point P is the point of the circle itself, therefore OP is also the radius of this circle, that is equals to capital R. You can see here that the length of AP, that is the diameter of the circle, equals to R plus R, that is 2R. In the next step, we will join points C and P together by a straight line. By joining points C and P, we created here peripheral angle ACP. This peripheral angle ACP rests on AP, that is the diameter of the circle. And we have here rule number 7 that states that any peripheral angle that rests on the diameter of the circle must be equal to 90 degrees. I repeat on rule number 7 again. We have here rule number 7. According to rule number 7, if a peripheral angle rests on the diameter of the circle, then it is equal to 90 degrees. Here we have peripheral angle ACB. This peripheral angle ACB rests on AB, that is the diameter of the circle. Therefore, this peripheral angle equals to 90 degrees. You can actually implement rule number 7 in normal drawing. Why? Because in normal drawing, we have here peripheral angle ACP that rests on AP, that is the diameter of the circle. Therefore, according to rule number 7, this peripheral angle ACP must be equal to 90 degrees. I will present to you rule number 8 and we will implement rule number 8 in our drawing. According to rule number 8, peripheral angles that rest on the diameter of the circle are equal to each other. In the drawing we have peripheral angle ADB that rests on chord AB, and we also have another peripheral angle ACB that rests on the same chord AB. So those two peripheral angles, they both rest on the same chord AB, therefore they are equal to each other. That is to say, if this peripheral angle ADB equals to theta, then the other peripheral angle ACB must be also equal to theta. So according to rule number 8, peripheral angles that rest on the same chord are equal to each other. We can actually implement rule number 8 in our drawing. Why? Because in our drawing we have this peripheral angle APC. This is peripheral angle APC that rests on chord AC. But we have another peripheral angle ABC. This is peripheral angle ABC that rests on the same chord AC. So actually, those two peripheral angles, that rest on the same chord AC must be equal to each other. So if we define this peripheral angle APC as theta, then the other peripheral angle ABC that rests on the same chord AC must be also equal to theta. This is according to rule number 8. So we'll focus on the right triangle APC. On the right triangle APC, this angle equals to theta. Again, on the right triangle APC, this angle equals to theta, this angle equals to 90 degrees, therefore the missing angle here must be equal to 90 degrees minus theta. Repeat again. The missing angle here must be equal to 90 degrees minus theta. Why? Because 90 degrees minus theta plus theta is 90 degrees, and 90 degrees plus 90 degrees, it is equal to 180 degrees. That is the sum of the angles in any triangle. Likewise, in the right triangle ABM, this angle equals to theta, this angle equals to 90 degrees, therefore the missing angle here must be equal to 90 degrees minus theta. In the next step, we will prove that the right triangle ABM is similar to the right triangle APC. So write it down. We will actually prove that the right triangle ABM is similar to the right triangle APC. So, why those two right triangles are similar to each other? First of all, those two angles are both equal to theta, therefore they are equal to each other. So, I write it down. This is angle ABM. It is equal to this angle APC. Repeat again. Angle ABM in triangle AMB equals to angle APC in triangle ACP. They are both equal to theta, therefore they are equal to each other. In addition, those two angles, they are both equal to 90 degrees, therefore they are equal to each other. So this is angle AMB. In triangle ABM, and it is equal to this angle, that is actually angle ACP. In triangle APC, they are both equal to 90 degrees. Repeat again. Angle AMB in triangle ABM equals to angle ACP in triangle APC. They are both equal to 90 degrees, therefore they are equal to each other. And finally, those two angles are both equal to 90 degrees minus theta, therefore they are equal to each other. So this is the angle MAB. And it is equal to this angle, the actual angle CAP. Repeat again. Angle MAB in triangle ABM equals to angle CAP in triangle APC. They are both equal to 90 degrees minus theta, therefore they are equal to each other. So actually proved that all the three angles in this triangle, triangle A and B, are correspondingly equal to all the three angles in this triangle, triangle APC. Therefore we actually proved that those two right angles are similar to each other according to angle similarity rule. So write it down. We actually proved that the right triangle, triangle ABM, is similar, this is the sign of similar, to the right triangle, triangle ACP, according to angle similarity rule. And from the fact that those two right angles are similar to each other, we derive that the following relationship exists between their sides. We derive that AB in triangle ABM over AP in triangle APC is equals to AM in triangle ABM over AC in triangle APC. Repeat again. We will derive that AB over AP equals to AM over AC. Okay, so actually AB is 13 over AP. AP is the diameter of the circle that is equals to 2R, and it is equals to AM. AM is 12 over AC. AC is 15. In conclusion, found out that 13 over 2R equals to 12 over 15. Here we cross multiply this equation and we get that 13 times 15 equals to 12 times 2R. Here we divide this equation by 12 and we get that 2R equals to 13 times 15 over 12. Here we divide this equation by 2 and finally we get that R equals to 13 times 15 over 2 times 12. And again, I found out actually that the radius of this circle R equals to 13 times 15 over 2 times 12. Here we divide both the numerator and the denominator of this expression by 3. In the numerator we have 13 times 15, so it will be 13 times 15 over 3 is 5, so in total after we divide the numerator by 3, we left only with 13 times 5 over 2 times 12. We divide the denominator of this expression also by 3, so the denominator will have 2 times 12, so it will be 2 times 12 over 3 is 4. So 13 times 5 is 65 and 2 times 4 is 8. So actually we found out that the radius of this circle R equals to 65 over 8 units. Our mission is to find out the area of this green shape. It is very easy to see from the drawing that the area of the green shape in total it is equals to the area of the circle minus the area of triangle ABC. Repeat again. From the drawing it is very easy to see that the area of the green shape in total is equals to the area of the circle minus the area of triangle ABC. So actually, the area of the green shape equals to the area of the circle, that is pi r squared, minus the area of triangle ABC. What is the area of triangle ABC? From the drawing it is very easy to see that the area of this triangle ABC equals to the base, that is BC, times the height to the base, that is H, over 2. Repeat again, the area of triangle ABC in total it is equals to the base BC times the height to the base, that is H, over 2. The area of the circle is pi r squared. R is 65 over 8, therefore r squared is 65 over 8 squared. So the area of the circle pi r squared is pi times 65 over 8 squared minus the area of triangle ABC. The area of triangle ABC equals to BC, that is 14, times H, that is 12, over 2. So actually, this expression in total it is equals to 207.394 square units minus the area of triangle ABC. The area of triangle ABC equals to this expression. This expression equals to 14 over 2 is 7, and 7 times 12 is 84. So in total the area of triangle ABC equals to 84 square units. And the area of the green shape in total it is equals to 207.394 minus 84, that is actually 123.394 square units. So we actually found out that the area of the green shape, according to the second method also, is equals to 123.394 square units. Okay. So in the next step, I'll summarize the lecture. We'll start with the first method, of course. In this lecture, I found out the area of this green shape. In the drawing, we have a circle. Inside this circle, we have triangle ABC. We know that side AB of this triangle ABC equals to 13 units in length, side BC equals to 14 units in length, and side AC equals to 15 units in length. Our mission is to find out the area of this green shape. In order to find out the area of the green shape, I presented to you rule number 4. We implemented rule number 4 in our drawing. So here we have triangle ABC. We know that the length of side AB is A, side BC equals to 2 units in length, and side AC equals to 3 units in length. And we also know that the semi-perimeter of this triangle ABC equals to the perimeter, that is the sum of its side lengths, that is to say it is A plus B plus C, and we will divide the perimeter by 2, we get the semi-perimeter. So the semi-perimeter of this triangle ABC equals to A plus B plus C over 2. Repeat again that AB equals to A units in itself, BC equals to B units in itself, and AC equals to C units in itself. So according to rule number 4, the area of this triangle ABC will be equals to the square root of S. S is the semi-perimeter, that is equals to A plus B plus C over 2, times S minus A, times S minus B, times S minus C. Again, A, B, and C are the lengths of this of the sides of this triangle, triangle ABC. So we can implement all number 4 in our drawing. First of all, we define the length of side AB as A and A equals to 13. We define the length of side BC as B and B equals to 14. And define finally the length of side AC of this triangle, triangle ABC is C. And we know that C equals to 15 according to what is given us the question. Repeat again. A equals to 13, B equals to 14, and C equals to 15 according to our definition. In the next step, we calculated the semi-perimeter of this triangle, triangle ABC. According to rule number 4, the semi-perimeter of this triangle, triangle ABC equals to A plus B plus C over 2. A is 13, B is 14, and C is 15 divided by 2. 13 plus 14 is 27, plus 15 over 2. 27 plus 15 is 42, and 42 over 2 is 21. So finally we found out that S equals to 21 units in its length. That is to say the semi-perimeter of this triangle, triangle ABC equals to 21 units. Again, A equals to 13, B equals to 14, and C equals to 15. The only thing that is left to do is to put the data inside the equation for the area of this triangle, triangle ABC. So the area of triangle ABC equals to the square root of S times S minus A times S minus B times S minus C. S is 21, S minus A is 21 minus 14, S minus B is 21 minus 14, and finally S minus C is 21 minus 15. So the area of triangle ABC equals to the square root of 21, and 21 minus 14 is 8, 21 minus 14 is 7, and 21 minus 15 is 6. 21 is 3 times 7, so we substitute 21 by 3 times 7. 8 is 2 times 2 times 2, so we substitute 8 by 2 times 2 times 2 times 7 times 6. We substitute 6 by 3 times 2. Then we arrange differently the numbers here and found out actually that the area of triangle ABC in total is equals to the square root of 3 times 3 times the square root of 7 times 7 times the square root of 2 times 2 times the square root of 2 times 2. The square root of 3 times 3 is 3, and the square root of 7 times 7 is 7. The square root of 2 times 2 is 2, and we have again the square root of 2 times 2 is 2. So in total, the area of triangle ABC equals to 3 times 7, that is 21, times 2 times 2. 21 times 2 is 42, and 42 times 2 is 84. So in total, we found out that the area of this triangle, triangle ABC, according to the new rule number 4, it is equals to 84 square units. Then I presented to you rule number 6, and we implemented rule number 6 in our drawing. According to rule number 6, in the drawing we have a circle. This circle blocks triangle ABC. We know that the length of side AB is A, side BC equals to B units in its length, and side DC equals to C units in its length. We define the radius of this circle as R. So the radius of this circle that is R, according to the new rule number 6, must be equal to A times B times C. That is the multiplication of the side lengths of the triangle ABC by each other, over 4 times the area of this triangle, triangle ABC, that is blocked by this circle. So we can actually implement rule number 6 in our drawing. Why? Because in our drawing we have a circle that blocks triangle ABC. According to the new rule, the radius of this circle, capital R, we define the radius of this circle as capital R. So according to rule number 6, capital R must be equal to A times B times C. That is the multiplication of the side lengths of triangle ABC by each other over 4 times the area of triangle ABC. And we have already found out that the area of triangle ABC equals to 84 square units. A is 13, B is 14, and C is 15 over 4 times the area of triangle ABC, that is 84. Then we divided both the numerator and the denominator of this expression by 14. In the numerator we have 14. 14 over 14 is 1, so we left, after we divided the numerator by 14, we left only with 13 times 15 in the numerator. In the denominator we have 14 times 84, we have 4 times 84, so it is 4 times 84 over 14 is 6. So in total, after we divide the denominator by 14, we left only with 4 times 6. Then we divided both the numerator and the denominator of this expression by 3. So in the numerator we have 13 times 15. So 13 times 15 over 3 is 5. So in total, after we divide the numerator by 3, we left only with 13 times 5. We have to divide the denominator also by 3. So in the denominator we have 4 times 6. So it is 4 times 6 over 3 is 2. So in total, after we divide the denominator by 3, we left only with 4 times 2, that is 8. In the numerator we have 13 times 5, that is 65. So actually found out that the radius of this circle in total, according to rule number 6, it is equal to 65 over 8 units. What is the area of the green shape? From the drawings, it's very easy to see that the area of this green shape equals to the area of the circle minus the area of triangle ABC. Repeat again. The area of the green shape equals to the area of the circle minus the area of triangle ABC. The area of the circle is pi r squared, and we already found out that the area of triangle ABC equals to 84 square units. So the area of the green shape in total equals to the area of the circle, that is pi r squared, minus the area of triangle ABC, that is 84 square units. R equals to 65 over 8, therefore r squared is 65 over 8 squared. So this expression in total equals to pi times 65 over 8 squared. Minus the area of triangle ABC, that is 84 square units. This expression in total equals to 207.394 square units. Minus the area of triangle ABC, that is 84 square units. 207.394 minus 84, it is equals to 123.394. So actually found out that the area of the green shape according to this first method equals to 123.394 square units. We finished with the first method. Then I presented to you how to find out the area of this green shape according to the second method. In the second method, we did the construction, that is to say, from point A, we do perpendicular on BC. So this angle equals to 90 degrees, and this angle equals to 90 degrees. According to our construction, we define the touching point of the perpendicular from point A in BC as M. Then we define the length of side AM as H, and we define the length of side BM as X. We know that BC equals to 14 units in itself according to what is given as the equation. So CB minus MB equals to CM. So CM equals to CB, that is 14, minus MB, that is X. So in total, CM equals to 14 minus X. Then I copied the right triangle AMB in a new page, and we implemented the Pythagoras theorem in this right triangle AMB. This is the right triangle AMB that I copied from the original drawing by BT is a version for Pythagoras theorem. AB equals to 13 units in itself according to what is given as the equation. AM equals to H, and BM equals to X according to our definition. In this right triangle AMB, according to the Pythagoras theorem, AB squared equals to AM squared plus BM squared. AB is 13, therefore B squared is 13 squared, that is 169, and it is equal to AM squared. AM is H, therefore AM squared is H squared, plus MB squared. MB is X, therefore MB squared is X squared. So actually found out that according to equation number 1, 169 equals to H squared plus X squared. We subtracted X squared from this equation number 1, and finally found out that according to equation number 1, H squared equals to 169 minus X squared. In the next step, I copied the right triangle AMC in the new page, and we implemented the Pythagoras theorem in this right triangle AMC. This is the right triangle AMC that I copied from the original domain. AC equals to 15 units according to what is given as the equation. AM equals to H according to our definition. And we have already found out that MC equals to 14 minus X. So in this right triangle AMC, by PT is the version for Pythagoras theorem. So according to the Pythagoras theorem, in this triangle AMC, AC squared equals to AM squared plus MC squared. I repeat again, in the right triangle AMC, AC squared equals to AM squared plus MC squared. AC is 15, therefore AC squared is 15 squared, that is 225, and is equal to AM squared. AM is 8, therefore AM squared is 8 squared, plus MC squared. MC is 14 minus x, therefore MC squared is 14 minus x squared. Here subtract the 14 minus x squared from this equation number 2, and finally found out that according to this equation number 2, h squared equals to 225 minus 14 minus x squared, while according to equation number 1, we have already found out that h squared equals to 169 minus x squared. So we have two different expressions for h squared. Therefore, we can get the equation number 3 that states that h squared according to equation number 1 must be equal to h squared according to equation number 2. H squared according to equation number 1 equals to 169 minus x squared, and it must be equal to h squared according to equation number 2. H squared according to equation number 2 equals to 225 minus 14 minus x squared. So according to this equation number 3, we found out that 169 minus x squared equals to 225 minus 14 minus x squared. 14 minus x squared equals to 14 squared, that is 196, plus x squared minus 2 times 14x, that is minus 28x. So according to equation number 3, we found out actually that 169 minus x squared equals to 225. Here we open the brackets, after we open the brackets, we get here minus 196 minus x squared, minus is plus, so this expression is equal to plus 28x. Here we have minus x squared on both sides of the equation, so minus x squared will get cancelled. After we cancel minus x squared, with this side of the equation we left only with 169. In the other side of the equation, we have 225 minus 196, that is 29, plus 28x. So according to equation number 3, we found out that 169 equals to 29 plus 28x. Here we subtracted 29 from this equation number 3, and found out that according to this equation number 3, 169 minus 29 is 140, so 140 equals to 28x. Here we divided this equation number 3 by 28, and finally we found out that x is equals to 140 over 28 is 5, so x equals to 5. And we have only found out that according to equation number 1, we have only found out that h squared equals to 169 minus x squared. That is to say, h squared equals to 169 minus x squared. But x is 5, but therefore x squared must be 5 squared, that is 25. So in conclusion, found out that according to equation number 1, h squared equals to 169 minus 25. 169 minus 25 is 144. So in conclusion, we found out that according to equation number 1, h squared equals to 144. We took out of this equation number 1, and finally found out that h equals to the square root of 144. The square root of 144 is 12. So finally we found out that x equals to 5 and h equals to 12 units in its length. In the next step, we define the center of this circle as O, and then we join points O and A together by side line. Point O is the center of the circle, point A is the point of the circle itself, therefore OA is the radius of this circle that is equal to, according to our definition, we define the radius of this circle as R. Then we extended the radius AO by a side line until it touches the circle. When we define the touching point of the extended radius AO with this circle as P. Again, point O is the center of the circle, point P is the point of the circle itself, therefore OP is also the radius of this circle that is equal to R according to our definition. AO is the radius, it is absolutely a straight line, and when we extend that straight line by straight line, the result AP must be also a straight line. AP is the straight line that touches the circle at points A and P, therefore AP is a chord. AP is a chord that passes through point O, that is the center of the circle. And any chord that passes through the center of the circle must be the diameter of the circle. Therefore, AP is the diameter of the circle. And you know that the diameter of the circle is twice as long as the radius. The radius is R, therefore the diameter AP is 2R. Then we join points P and C together by a straight line. In this way, we created peripheral angle ACP. This peripheral angle ACP rests on AP, that is the diameter of the circle, and we have rule number 7 that says that any peripheral angle that rests on the diameter of the circle must be equal to 90 degrees. I repeat again on rule number 7. According to rule number 7, if a peripheral angle rests on the diameter of the circle, then it is equal to 90 degrees. In the drawing, we have peripheral angle ACB that rests on AB, that is the diameter of the circle, therefore peripheral angle ACB equals to 90 degrees. So we can actually implement rule number 7 in our drawing. Why? Because in our drawing we have peripheral angle ACP that rests on AP, that is the diameter of the circle, therefore according to rule number 7, this peripheral angle ACP must be equal to 90 degrees. Then I presented to you rule number 8 and implemented rule number 8 in our drawing. According to rule number 8, peripheral angles that rest on the same chord are equal to each other. Here we have peripheral angle ADB that rests on chord AB, and we have another peripheral angle ACB that rests on the same chord AB. So those two peripheral angles, they both rest on the same chord AB, therefore they must be equal to each other. That is to say, if this peripheral angle ADB equals to theta, then the other peripheral angle must be also equal to theta. So we can actually implement rule number 8 in our drawing. Why? Because in our drawing we have peripheral angle APC that rests on chord AC, and we have another peripheral angle ABC that rests on the same chord AC. So actually those two peripheral angles, they both rest on the same chord AC, therefore they must be equal to each other. That is to say, if peripheral angle ABC equals to theta, then the other peripheral angle APC that rests on the same chord AC must be also equal to theta. According to rule number 8, of course. So if we focus on the right triangle APC, this angle equals to theta, this angle equals to 90 degrees, therefore the missing angle must be equal to 90 degrees minus theta. Why? Because 90 degrees minus theta plus theta is 90 degrees, and 90 degrees plus 90 degrees, it is equal to 180 degrees. That is the sum of the angles in any triangle. Likewise, in the right triangle ABM, this angle equals to theta, this angle equals to 90 degrees, therefore the missing angle here must be equal to 90 degrees minus theta. In the next step, we proved that the right triangle ABM is similar to the right triangle APC. So why those two right triangles are similar to each other? First of all, those two angles are both equal to theta, therefore they are equal to each other. In addition, those two angles are both equal to 90 degrees, therefore they are equal to each other. And finally, those two angles are both equal to 90 degrees minus theta, therefore they are equal to each other. So we actually proved that all the three angles in triangle ABM are correspondingly equal to all the three angles in triangle APC, therefore those two right triangles are similar to each other according to angle similarity rule. And from the fact that those two right triangles are similar to each other, we will derive that the following relationship exists between their sides. We will derive that AB in triangle AMB over AP in triangle APC equals to AM in triangle AMB over AC in triangle APC. I repeat again, we derive that AB over AP equals to AM over AC. AB is 13, AP is the diameter of the circle, that is 2R, AM is 12, and AC is 15. So in conclusion, we found out that 13 over 2R equals to 12 over 15. Here, of course, multiply this equation, and we found out that 13 times 15 equals to 12 times 2R. We divided this equation by 12, and finally found out that 2R equals to 13 times 15 over 12. Here we divided this equation by 2, and finally found out that the radius of this circle R equals to 13 times 15 over 2 times 12. Here we divided both the numerator and the denominator of this expression by 3. In the numerator we have 13 times 15. So it is 13 times 15 over 3 is 5. So after we divided the numerator by 3, we left only with 13 times 5. In the numerator we have 2 times 12. So it is 2 times 12 over 3 is 4. So after we divided the denominator by 3, we left only with 2 times 4, that is 8, and 13 times 5 is 65. So in total, we found out that the radius of this circle R equals to 65 over 8 units. What is the area of the green shape? The area of the green shape from the drawing, it is very easy to see that the area of this green shape equals to the area of the circle minus the area of triangle ABC. I repeat again, the area of the green shape in total is equals to the area of the circle minus the area of triangle ABC. The area of the circle is pi r squared, and the area of triangle ABC, what is the area of triangle ABC? From the drawing, it is very easy to see that the area of this triangle ABC equals to the base of the triangle that is BC times the height to the base that is h over 2. And repeat again, the area of triangle ABC equals to the base that is BC times the height to the base that is h over 2. So the area of the green shape in total is equals to pi r squared. R is 16 over 5, therefore r squared is 16 over R is 16 over 8, therefore R squared is 16 over 8 squared. So pi R squared in total equals to pi times 65 over 8 squared minus the area of triangle ABC. The area of triangle ABC equals to BC, that is 14, times H, that is 12 over 2. This expression in total equals to 207.394 square units. This expression equals to 14 over 2 is 7, and 7 times 12 is 84. So the area of triangle ABC in total equals to 84 square units, and the area of the circle equals to 207.394 square units. 207.394 minus 84 is equals to 123.394. So actually found out that the area of this green shape in both methods is equals to 123.394 square units. Okay, thank you very much.